Hello everyone! Today we will continue to look at the content of HCIA-Storage. Previously, we have already introduced various metrics and parameters of hard drives, including the composition of hard drives, storage, transmission, and so on. Today we have officially reached the most important metric of our hard drives, which is our IOPS. This IOPS, when translated, actually means the total amount of input, and output per second of our hard drive, or the number of read and write operations. It is the primary metric for measuring the performance of a hard drive. Simply put, if we consider the hard drive as a data processing factory, this IOPS actually represents the number of orders the factory can process per second. For example, in scenarios like databases where there are frequent read and write operations, the higher our IOPS, the better. The response speed of the database may also be faster. This allows us to retrieve the data we need more quickly. So, how is this calculated? First, it involves seek time, rotational latency, and our data transfer time, which consists of these three parts. First, seek time refers to the time it takes for the read-write head to move back and forth between different tracks on the hard drive to locate data. Right? We've mentioned before that the time spent on this automatic movement is called seek time. This is similar to when you go to different places. In the city, the time you spend moving between streets to pick up things is essentially our seek time. Then, the second is rotational latency. That is, after the head is positioned on the track, right? How long do we need to wait? As we mentioned before, the maximum waiting time is actually determined by our rotational speed. You can divide 1 second by the rotational speed, or divide 60 seconds by the rotational speed to get the result. This time is the duration of one full rotation, and the maximum time is actually the time for one full rotation. On average, it's half of that, so the average is half of your maximum time. This is what we call rotational latency. The final data transfer time is the time taken by the read-write head to read or write data. The sum of these three times determines the time required for the disk to complete one input-output operation. This in turn affects the value of our IOPS. This is what we have. Using these three, we can calculate the value of our IOPS. This is actually one of the basic and most important indicators of performance for our hard drive, a primary indicator of performance. Let's take an example. The impact of IOPS on practical applications can be seen, for instance, in the back-end database of a large e-commerce website where every day we have a large number of users conducting product searches. Or placing orders and other operations. What do these operations involve? They involve the database and frequent read and write operations on the hard drive. If your hard drive's IOPS is relatively low, what situation might occur during peak user access times? You might experience slow page loading or order failures, among other issues. However, our high IOPS hard drives can respond to these read and write requests much faster, enhancing the user's shopping experience. This is actually one of the main benefits of having a high IOPS value. Its main purpose is to demonstrate our performance. The basic performance issue of the disk. This is what our IOPS represents. Next, the second metric we see here is transfer of bandwidth, or throughput. Outbound bandwidth or throughput. This mainly refers to the amount of data successfully transferred in a unit of time. In other words, it's the speed of our data transfer stream. You can think of it as a data transfer highway. The wider the highway, the more cars can pass through in the same amount of time, meaning more data can be transferred. This is actually the main one of our bandwidth transmission bandwidth concept. Now regarding the calculation method. First of all, let's assume, for example, I write 10,000 1 KB files and it takes 10 seconds. So I write the total amount of 10,000 1 KB files is actually equivalent to what? It's equivalent to 10,000 KB, which converts to 10 megabytes because 11 megabyte equals 224 KB. Here we can simplify the calculation. For example, 10,000 KB is equal to 10 megabytes. At this point, our transmission bandwidth can reach what? It can reach 1 Mbs to 1 Mbs. If I put it another way, if writing a 10 MB file takes 0.1 seconds, then what would be the bandwidth? It would be 100 MBs. By calculating this way, we can actually know how fast our data transmission rate is. Actually, this data transmission rate is. Or in other words, bandwidth is the size of the file we can transmit per second. The size of the file we can transmit per second. This transmission bandwidth, actually, its importance is the same as the IOPS we mentioned earlier. Both are very important, but they are two different aspects. However, in our IOPS, for example, when you go to access some of these websites, access some apps, or to be more direct, when you download something like music or movies, at that time, if the transmission bandwidth is high, it can greatly shorten your download time. This is one of the main advantages of our transmission bandwidth. At this time, for scenarios that require the transmission of large amounts of data, such as image rendering and video editing, this transmission bandwidth becomes very important. If your bandwidth is insufficient when loading these large images or graphics, it will cause lag, which can significantly affect our work efficiency. This is actually one of our concerns. Transmission bandwidth for our overall. The impact on the scenario is mainly in this aspect. So overall, we can compare these two, our hard drives, IOPS, and transmission bandwidth. Actually, what does IOPS focus more on? It focuses more on measuring the number of read and write operations a hard drive can complete per second. And here, we want to make it read and write faster. The main thing is to improve the various metrics we mentioned earlier, such as storage, transmission, seek numbers, seek speed, wait time, and so on. This focuses more on the random read and write performance of our hard drive. And the concept of bandwidth, what does it focus more on? It focuses on the total amount of data that can be successfully transmitted in a unit of time. It is concerned with the data transfer speed of the hard drive. In practical applications, we actually choose the appropriate hard drive based on different needs. For example, what do we need more in a database server? We need higher IOPS to quickly respond to read and write requests, right? We also need to have enough transmission bandwidth to handle large amounts of data. In a scenario like a database, both of these need to be higher. Yes, they both need to be higher. This is one of our points. Well, this is a main comparison between the two. Actually, overall, for hard drives, both are very important. Indeed, both are very important. As I said before, both are the same. The faster, the better. Higher IOPS is better. And higher bandwidth is also better. Of course. Pay attention if you have particularly high requirements. It's necessary. The cost will also be relatively higher, which is quite normal. This is very normal. So here, you need to choose based on your actual needs. You can't just say you want the fastest, but then find out that the order is extremely expensive. So as long as this thing meets your needs, it's fine in terms of IOPS. If your read-write requirements are not particularly high, then actually using the most basic hard drive is sufficient. You don't need to choose the extremely high-end ones, as those are actually very expensive. It's like you could use a mechanical drive, but you insist on buying a solid-state drive. In this case, you end up spending more money. However, the experience isn't significantly different. This is essentially the issue here. This relates to the IOPS and transfer bandwidth of our hard drives, which are two very important metrics for our drives. These are the metrics that measure the performance of our hard drives, and this is the content of our lesson today. If you're interested in learning Huawei serious technology or want to access the Huawei question bank, please send me a private message. You can also leave comments below the video for technical discussions. Alright, let's stop here for today.